In last session, we study about two cases of graphical solution. Now, we study about the remaining three special cases of graphical solution. In three special cases of graphical solution is one is infeasible solution, second one is unbounded solution, and third one is alternative multiple solution. Three solutions. Three special cases are remaining. So we start our next case, example number 3, case for alternative solution. Alternate solution means we have two solutions. For example, consider the example, maximum z is equals to 10x plus 6x to subject to this constant equation 5x1 plus 3x2 is greater than equal to 30, x1 plus 2x2 is greater than equal to 18, and x1 and x2 is greater than equal to 0. Same, we want to solve this question by the use of graphical method. So, we assume on the horizontal axis variable x1 and on the vertical axis variable x2. After that, our first constant equation is 5x1 plus 3x2 is greater than equal to 30. For this equation, we find out the point for creating for drawing a line. So same method, if our x1 is 0, then if x1 is 0, that means 3x2 is equals to 30 and x2 is equals to 10. If we put x2 is equals to 0, then equation is 5x1 is equals to 30 means x1 is equals to 6. So here we find out the two arbitrary points for the line 5x1 plus 3x2 is greater than equal to 30. And point is 0 and 10 and 6 and 0. Our second equation is x1 plus 2x2 is greater than equal to 18. So here, if our variable x1 is 0, then 2x2 is equals to 18 means x2 is equals to 9. If our variable x2 is equals to 0, then x1 is equals to 18. So we find out our 2 points for the line x1 plus 2x2 is greater than equal to 18. First point is 0 and 9, second point is 18 and 0. Now we draw the line on the graph. For the first line 5x1 plus 3x2 is greater than equal to 0. First point is 0 and 10. Means x1 is 0 and x2 is 10. So mark out that point. Now second point is 6 and 0. Mark that point. 6 and 0. Now we have 2 points. So draw the line by joining of that 2 points. Now for the second line x1 plus 2x2 is greater than equal to 18. Our first point is 0 and 9. And second point is 18 and 0. Mark that 2 points and after mark of the 2 points, join the 2 points. This is the line for the second x1 plus 2x2 is greater than equal to 0. So greater than equal to 18. After the next, now in the next step, we consider the feasible region. So First equation is 5x1 plus 3x is greater than or equal to 30. Means in this equation, sign is greater than or equal to, so area of that equation will be considered over the line, over the origin. In the second constraint, x1 plus 2x is greater than or equal to 18. Again, sign is greater than or equal to, so area will be considered the on or below the line means over the origin. Now find out the common area of that two constraint equation. So which one is this one area is the common area. Area shaded by the blue line is the common area of that two constraint equation which is known as feasible region. After finding the feasible region, mark the corner point, corner intersection point in that region. So our first point is origin point O, second corner point is this one which having name A, next corner point is this one with name B, and next corner point is this one which name is C. After finding the common point, value of that point is value of the point O is 0 and 0. Point A is 6 and 0 and point C is 0 and 9. For the point B is the intersection point of the both constraints. So solve the both equation 5x1 plus 3x is equals to 30 and x1 plus 2x is greater than or equal to 18 and determine the value of B. Here value is 4.0, 0 and 0, A 0 and 9, B 6 by 7 and 60 by 7, and C 6 and 0. Now find out the value of Z. For the point O, value of Z is 0. For the point A, value of Z is 54. For the point B, value of Z is 60. And for the point C, value of Z is 60. So, in this equation, we want to determine the maximum value of the Z. And here maximum value of Z is 60, which occurs at the 2 points B and C. In both points, maximum value of Z is equal, and that is 60. And that is 60. There at point B and C, value of Z are same and maximum. So the solution of given LPP are x1 and x2 is equals to 6 by 7 and 60 by 7 and maximum Z is equals to 60, or x1 and x2 is equals to 6 and 0 and maximum Z is equals to 60. Both solutions are right. If someone written the solution for the point B, that means x1 and x2 is equals to 6 by 7 and 60 by 7 and maximum Z is equals to 0. This one is also right. And if someone write the solution 6, 0, x1 and x2 is 6 and 0 and maximum Z is 60, then this one is also right. Here maximum value of Z is at 2 points. Therefore, this is a case of alternative solution. More than one solution is possible. Alternative solution means more than one solution is possible. And in this example, we have two solutions. 6 by 7 and 60 by 7 or 6 and 0. Both solution of x1 and x2 is right. Now, after that, we will consider a case of unbounded solution. Now, we will consider the case of unbounded solution. Means our feasible area is not bounded. Our feasible area is not bounded. For that, then I will consider an example. Maximum z is equals to 3x1 plus 2x2 subject to 5x1 plus x2 is greater than or equal to 10, x1 plus x2 is greater than or equal to 6, x1 plus 4x2 is greater than or equal to 12, and x1 and x2 is greater than or equal to 0. Same procedure are here. Assume the variable x1 on the horizontal axis and variable x2 on the vertical axis. Now find out the point for the first constant equation. 5x1 plus x2 is greater than or equal to 10. If x1 is 0, then x2 is 10. And if x2 is 0, then 5x1 is equals to 10 means x1 is equals to 2. So we determine the two points value for the line 5x1 plus x2 is greater than or equal to 10. Now for the second line, x1 plus x2 is greater than or equal to 6. If x1 is 0, then x2 is 6. And if x2 is 0, then x1 is 6. So then we determine the two value for the line x1 plus x2 is greater than or equal to 6. Now the third constant equation x1 plus 4x2 is greater than or equal to 12. Same process, put the value of x1 is equals to 0, then x2 is equals to 3, and if we put x2 is equals to 0, then x1 is equals to 12. Arbitrary points of all the constant equations are declared. Now draw the graph. For the first constant equation, mark the first point 0 and 10. Now second point 2 and 0. Draw that 2 point. By the joining of that 2 point, a line will be drawn. Now for the second equation, x1 plus x2 is greater than or equal to 6. First point is 0 and 6, and second point is 6 and 0. Join that 2 point over second line, x1 plus x2 is greater than or equal to 6. Now third line, x1 plus 4x2 is greater than or equal to 12. First point is 0 and 3, and second point is 12 and 0. Mark both the point. Now join that both point over graph prepared. Now in the next step 5, determine the feasible region. For determining the feasible region, we determine a area. Which one area bounded by the line, by the constant equation. So for the first constant equation, 5x1 plus x2 is greater than or equal to 0. Over sign is greater than or equal to. That means area will be considered on and above the line. That means away from the origin area will be considered for the first constant equation. For the second constant equation, 5x1 plus x2 is greater than or equal to 0. Here sign is greater than or equal to 0. For that constant equation, area considered will be on or above the line. Means away from the origin area will be considered. Same for the third constant equation, x1 plus 4x2 is greater than or equal to 12. Sign is greater than or equal to. For that constant equation, area also consider the on or above the constant line. Means away from the origin. So here which one is the common area? Here common area is the this one. This one is completely common area which is represented by the blue lines. This one is the common area which known as feasible region. Now Our next step is mark out the corner point. Here, our feasible region is not bounded. This feasible region is bounded with the lower boundary, but not bounded with the upper boundary. And in this problem, asking about the maximum of Z. So, for determining the maximum of Z, we require here bounded area. Why? Because of from the upper boundary, for the upper boundary, no any point we mention here. Here, feasible region is not bounded, therefore it is an unbounded solution. This is simple answer. Here we write only one line. Feasible region is not bounded, therefore that is an unbounded solution. That is an unbounded solution. Now we move over last special case of graphical method, which one is infeasible solution. Infeasible solution. For that, I consider a problem arrange maximum z is equals to 6x1 minus 4x2 subject to 20x1 plus 4x2 is greater than equal to 4, 4x1 plus 8x2 is greater than equal to 6, king, and x1 and x2 is greater than equal to 0. Same procedure apply. Assume x1 on the horizontal axis, x2 on the vertical axis. Determine the 2 points of the constraint equations 2x1 plus 4x2 is greater than equal to 4. 2 points is 0 and 2 and 0. For the constraint equation second, 4x1 plus 8x2 is greater than equal to 16. 2 point x 0 and 2 and 4 and 0. Now draw the graph. For the first constraint equation, first point is 0 and 1. Mark that point. Second point is 2 and 0. Mark that point. Draw the both. Join the both point. Draw our first line. For the constraint equation, 2x1 plus 4x2 is greater than equal to 4. Now second constraint equation, 4x1 plus 8x2 is greater than equal to 16. Mark the first point 0 and 2 and second point 4 and 0. Join both points. This one is the rhyme for our second constraint equation. 4x1 plus 8x2 is greater than equal to 16. Now, area considered for the feasible region. In the first constraint equation, 2x1 plus 4x2 is greater than equal to 4. Sign is the greater than and equal to. And I already told you for the greater than and equal to area considered will be on or below the line. Means toward the origin. Area will be considered. Now for second constraint equation, 4x1 plus 8x2 greater than equal to 16. Area considered is on or above the line. Why? Because here sign is greater than equal to 0. So on or above the line. Now what happened in this problem? In this problem, no any common area. In this problem, no any common area means feasible area is not determined. For the first constraint equation, area considered will be this one over the origin side. And for the second constraint equation, area considered will be away from the origin side. Means no any common area. So here is not a common area identified. That means feasible region is not determined. Therefore, that is an infeasible solution. In this type of problem, only we write one line, no any feasible area is determined, therefore that is an infeasible solution. So, in the complete today session, we discuss about the graphical method of RPP. We solve the how could how we solve the RPP problem with the use of graphical method. What is the procedure of graphical method? And in the graphical method, we discuss about the unique solution with maximization type of problem, unique solution with minimization type of problem, alternative solution, unbounded solution, and infeasible solution. Five cases are possible in the graphical method. So we discuss in today's session all of the five cases discussed in today's session. Thanks everyone. If you have any type of doubt regarding RPP formulation and RPP solution with the help of graphical method, then just WhatsApp me on same or special WhatsApp group or my or WhatsApp me individually on my mobile number 99290305333, or you can mail also. Mail ID is skcat tech education education @gmail.com. Thanks everybody.